Welcome to this presentation on computer memory, ROM, RAM, cache, and virtual memory. This presentation has been prepared by Professor Gottappu Sasibhushan Rao, Senior Professor, Department of ECE. Computer memory stores the instructions, data, and intermediate results required by the processor. A simple memory hierarchy is registers, cache, RAM, and secondary storage. As we move down this hierarchy, speed generally decreases, while storage capacity increases. RAM, or random access memory, is the main working memory of a computer. It temporarily stores the programs and data currently being used by the CPU. RAM supports both reading and writing, but it is volatile, so its contents are lost when power is switched off. The two common types are SRAM, mainly used for cache memory, and RAM, mainly used as main memory. ROM, or read-only memory, is a non-volatile memory. Its contents remain even when the power is switched off. ROM is mainly used to store permanent instructions such as firmware and boot programs. Common types include PROM, EPROM, EPROM, and flash memory. Cache is a small and very fast memory located close to or inside the CPU. It stores frequently used instructions and data, reducing the time required to access RAM. If the required data is found in the cache, it is called a cache hit. If it is not found, it is called a cache miss, and the data is fetched from RAM. Cache is commonly organized as L1, L2, and L3 levels. Virtual memory is not a separate physical memory chip. It is a memory management technique used by the operating system. When RAM becomes insufficient, part of the SSD or hard disk is temporarily used as additional memory. For example, if a computer has 8 GB of RAM and the running programs require more memory, some less frequently used data can be transferred to secondary storage. This additional storage space acts as virtual memory, although it is much slower than RAM. Registers are very small and extremely fast storage locations located inside the CPU. They temporarily hold instructions, addresses, operands, and intermediate results required by the processor. In contrast, secondary memory provides long-term storage. Examples include SSDs, hard disks, USB drives, and memory cards. Secondary memory is non-volatile and provides much larger storage capacity, but it is slower than RAM. This slide summarizes the main types of computer memory. Registers are the fastest, followed by cache and RAM. ROM provides permanent storage for firmware and boot instructions, while virtual memory extends the available RAM using secondary storage. Secondary memory provides the largest and most permanent storage. In simple terms, registers and cache provide speed, RAM provides working space, ROM stores permanent instructions, and secondary memory provides long-term storage.